This video is going to start looking at statistics. It's quite a large chapter, quite a large chunk of your paper too, so I'm going to break it up into a number of bite-sized videos, and I'll take you through the whole, what I call, data handling cycle. So to explain what I mean by the data handling cycle, which really does sum up the whole chapter on statistics for you, I want to draw this diagram. So on any data gathering exercise, you pose a question. In other words, you have some question you need answered, and to do that you need to gather a body of data, you'll need to analyze the data, and then you'll need to draw conclusions from it. Now, all you have to do is look around you at this, because we're in the middle of COVID-19, and you can look at the questions that are being posed, the data that is being gathered around the world on a daily basis, the analysis of that data to try and figure out what is the best way to maneuver our way through COVID-19, and then eventually let us find our way out of this isolation that we find ourselves in. So I'll probably refer back to COVID-19 again and again because it's very current and it's very statistics based. So we're going to pose a question. We're then going to design some sort of a survey or an experiment, or we're going to do research on the internet. But in some way or other we are going to collect data around our question to help us answer that question. So I'll take you through what's primary data, I'll take you through what's secondary data, and what are the difference between them. Okay, we then will need to analyze that data or do some analysis of data. Okay, and beforehand we often chart our data. Why? Because it's much easier to look at a body of data in picture format than it is in a table or pages and pages of Excel data. So we often chart our data before its analysis. But somehow or another we're going to analyze our data, and we're going to do this through statistical measures, often called measures of center, which is your mean, your mode, and your median, are the ones in your course. We're also going to look at measures of variability. Range would have been the easiest one that you would have done in Junior Cert for sure. Interquartile range also done in Junior Cert, and then standard deviation, which is the most important one as you progress through your course on stats. And then you're going to do some sort of interpretation of your results, which may then force you to pose another question and go through the process again. So this is why it's a data handling cycle rather than just one loop. You may end up going round and round this as you tweak your question, as you tweak your process to help you gather data about whatever it is you're trying to understand or solve. To interpret the results could mean a few things. You could just be looking at your sample of data that you have gathered, and you might be trying to come up with a solution for the entire population. So we'll look at that. We'll look at what does that mean when we just look at the data around the sample that we've taken or the charts that we've drawn. We call that descriptive statistics. In other words, we're describing the data we just gathered. When we try and use that sample data to come to some sort of a conclusion about an entire population, where we haven't gathered data on the entire population, but we would like to make a statement about the entire population. So in other words, as an example, if you wanted to know what was Ireland's favourite TV programme last Saturday night, what was the majority of people viewing, well, you're not going to ask everybody in the country, you're going to take a sample, but you are going to make a conclusion about what is the favourite TV programme that Irish people watched last Saturday. So when you make inferences or you make conclusions about an entire population, this is what we call the branch of inferential statistics. And hypothesis testing and so on and so forth fits into this branch of statistics. So we'll get to that towards the end of the statistics course. So this data handling cycle here is your entire statistics chapter basically, and probability weaves its way in between it. In other words, when you make an inference about the population, what's the probability that it comes true, what's the probability that it doesn't, so on and so forth. Okay, what's the probability of error in your data? Have you any false positives, false negatives, so on and so forth. Okay, so probability and statistics weave among each other. Okay, so let me stop sharing there now for a minute and I'll just go back to your book. Okay, so statistics. Statistics deals with the collection, presentation, analysis and interpretation of data. Insurance of people and property, which now dominates many aspects of our lives, utilizes statistical methodology. Social scientists, psychologists, pollsters, medical researchers, governments, so on and so forth use statistical methodology to study populations. In other words, what that's trying to say is that in any branch of life we will use statistics to, I suppose, analyse what is happening around us. There's a lot of words you need to know for this chapter. You could be asked them to explain them. You could be asked what do they mean in your exam. So these are the ones you need to know. You need to know what is a variable. So a variable is a characteristic of interest in each element of the sample or population. In other words, it's what you're trying to measure, it's what you're trying to figure out. In this case, we may be interested in the age of each of the 7 dwarfs. An observation then is the value of a variable for one particular element of the sample. So in other words, if you're doing an experiment, it would be what value you got. So it's an observation. A data set then is all of the observations of a particular variable. So it's a complete data set. So in this case, all of the ages of the 7 dwarfs. Okay, so then when you're collecting data, you can either collect data of an entire population, and that's called a census, or you can calculate data from a subset of the population, and that's called a sample. So the population is a complete set of data under consideration. For example, a population may be all the females in Ireland between the ages of 12 and 18. So it doesn't necessarily have to be everybody in Ireland, but it has to be everybody that falls within whatever category you specify. So the category specified here is those girls between 12 and 18. So if you were going to look at the entire population in Ireland, then you have to look at survey every girl between 12 and 18. A census, if anybody's heard of it, is a collection of data relating to a population. So every 4 years in Ireland, the government does a census, which is a big huge survey about everybody in the country, and everybody who's in a particular house on a particular night has to fill in this census, and that's how they figure out data or statistics on where a country is and how many's working and so on and so forth. A list of every item in a population is called a sampling frame. A sample then, on the other hand, so question often is the difference between a population and a sample. A sample is a small part of the population selected. The best sample to choose is what's called a simple random sample. And a random sample is a sample in which every member of the population has an equal chance of being selected. So in other words, you assign everybody in Ireland a number from 1 to whatever population we have in the country, and then you let a number generator automatically choose whatever sample size you're looking for. So if it was 1,000 people, you'd let the random number generator select 1,000 numbers from 1 to 4 million or whatever is in the country. Okay, so that's how you do a random sample. Data gathered from a sample are called statistics. Conclusions drawn from the sample can then be applied to the whole population. This is called statistical inference. However, it's very important that the sample chosen is representative of the population to avoid bias. So what does that mean? Well, for a sample to be representative of the population, then it has to take data from every possible type of person within the population, or every type of sample. So in other words, that question I asked about what was the entire country watching last Saturday night, it's not okay just to take your sample from a group of 50-year-olds. 50-year-old females, for example, because what they watch would be very different from what men watch, or could be very different from what men watch. It would be very different from what teenagers watch, which would be very different from what children watch, and so on and so forth. Okay, so to have a representative sample, you need to take a number of people from every different age group, from every gender, and so on and so forth within the country. So that's what's called a representative sample. So when would you take a sample and when would you take a population? Is one better than the other? Well, obviously a population is much better, because when you take a population, when you do your survey on an entire population, everybody has a voice. So the data you gather is very much representative of that entire population because you've asked everybody. Okay, so why don't we do surveys on entire populations? Well, that's because it's so expensive. It's very time consuming. It's very hard to get every single person or in a population, or every different, I suppose, element in a population. It's very hard to get them. So it's much easier to take a sample of that population. And then you have to be careful that your sample isn't biased. In other words, you're not taking it from a specific subset. You have to be careful that it's a large enough sample. And so on and so forth. So bias then is unfairness. It's anything that distorts the data so that they will not give a representative sample. So bias can occur in sampling due to 1. Failing to identify the correct population, 2. A sample size that is too small, or using a sample that is not representative, 3. Careless or dishonest answers to questions, 4. Using questions that are misleading or ambiguous, 5. Failure to respond to a survey, 6. Errors in recording the data, for example, recording 23 as 32, that's if you were writing down the answers to a survey or somebody did a typo. 7. The data can go out of date. Okay, so that's how you end up with bias in your data, and sometimes you didn't even mean it to happen. Bias is extremely important, and it's extremely important for your generation, because much more things are being fitted with artificial intelligence, and when something is taught or programmed to think for itself, you have to be careful that you don't program it with bias. And there's loads of examples on this on the internet, and it's a really interesting area that some of you is going to end up working in. So bias, very topical at the moment. So why would you use a sample instead of a population? Well, they're fast and cheap. 2, it's essential when the sampling units are being destroyed. That's a very good point. In other words, if you were figuring out the lifetime of batteries, for example, then you have to use those batteries until they're wasted. So once you do that, then that battery goes in the bin. So you obviously couldn't do that type of a test. It's called a destructive test on the entire population, because you'd end up with no batteries. So you can only do it on a sample. 3, the quality of information gained is more manageable. So in other words, you don't end up with too much data if you take a sample, and it's better controlled, leading to better accuracy. And 4, it's often difficult to gather data on a whole population. Okay, so how do you gather this data? Well, in many cases you have to design a sample or you have to design a set of experiments. So let's have a look at a survey first. A survey collects data or information. A sample survey is a survey that collects data from a sample of the population, typically using a questionnaire. Questionnaires are well-designed forms that are used to conduct sample surveys, and it's not the easiest thing to do is to design a questionnaire or a good questionnaire. And I'll get onto that in a minute. So the main survey methods, so how would you survey people? Well, you would survey them using a personal interview. This is very good. One big advantage of this is people are asked the questions directly. It's much harder for you to lie when you're asked a question directly. And this is regularly used in market research. Downside of it is it's very time consuming and very costly. You can also do a telephone survey. It's often used for a personal interview. You can get a much larger sample if you do a telephone survey because it's faster. You don't have time wasted driving to meet people or so on and so forth. But again, it's a little bit easier for people to lie over the phone. Postal survey, where you post it out to their address. A dying trend, I would say. An email survey is probably, or an online survey is probably much more common than a postal survey. However, the advantage of that is, again, you can get a much larger sample size because you're just blasting off letters and they're posting them back to you. Again, you may get incorrect or careless or dishonest answers, so you may end up with bias. Somebody may not understand your question, so you may end up with incorrect data. So you have to be careful. Online questionnaires, by far and the most popular at the moment, where it's filled out online. SurveyMonkey or Google Survey or one of those. So this is a really good table, and I've seen this being asked probably in a mock before, is the advantages and disadvantages of the 4 types of surveys. So take a few minutes, read through that table. I'm not going to read it for you because I assume you can read, so just pause the video, read it. It is a little bit of common sense, but you just need to read it and get those words into your head. No harm to do out little cheat sheet or some sort of notes on this particular video for you, so that this stuff you can just flick through and before your exam, whenever that ends up being, just before your paper 2. Okay, so that's a survey, very common for gathering data, but there are other ways. An experiment is also really important. So experiments are going to be so common as we strive to find a vaccination for COVID-19. So the only way they can find out if the vaccine that they come up with kills the virus is through experiments. So it's a controlled study in which the researcher understands cause and effect relationships. So in other words, if they come up with a vaccine that doesn't cure the virus or kill the virus, they have to understand the effects of their vaccine, they have to understand what caused it, and they have to do that so they can be able to tweak the vaccine to make it ideal for killing the virus. So it's very much a controlled study, and it's very popular with drug companies testing a new drug. Okay, observational studies then are when the data is collected by counting, measuring or noting things that happen. So traffic is a very common one for observational studies. You might be trying to figure out how many cars pass over a bridge on a particular time of the day. Well, then you just have a person stand at that bridge and count the cars. Would be used by civil engineering for road planning, for bridge design if they needed to strengthen the bridge, widen the bridge, so on and so forth. So important factors are place, time of day and the amount of time spent collecting the data. Its disadvantages, it's laborious and it's time consuming. Okay, a designed experiment then, data obtained by an experiment is called a designed experiment. In other words, you've designed the experiment in the first place. The data is collected by counting or measuring, either throwing a dice or tossing 2 coins a number of times and recording the results. Okay, so just know the difference between an experiment and then what's called a designed experiment. So an experiment is something in a lab. You're collecting lab data. A designed experiment is just, I suppose, an event that you design, a controlled event that you design to gather the probability of something happening or something like that. So the key things to remember with the designed experiment is that it must be repeated a number of times and that the experiment must be capable of being repeated by other people. Data capture is the process by which data is transferred from a paper copy, e.g. a questionnaire, to an electronic file, usually on a computer. Okay, why would we do data capture? Obviously, it's much easier to keep a body of data online or electronically than it is with a paper copy. Paper copy, you have to file away, you have to lock in a cabinet for data protection, so on and so forth. It's much easier to put that data into an online file, encrypt the files, so again for data protection, and then you can destroy the paper copies. It is also much easier to have software generate the charts from your data so that you can analyze your data. So just going back to that data handling cycle. So and there's many pieces of software for drawing charts. Probably the one you know best is Excel. So Excel can generate histograms, bar charts, scatter diagrams, so on and so forth. So data is often entered into a computer to allow it to store the data and generate charts. So I mentioned when I was drawing the data handling cycle, primary data and secondary data. So very important that you know the difference between them. It may come in this book yet, it probably will, but just in case it doesn't, I'm going to talk about it now. Primary data is data that you gather yourself. So it is the questionnaire that you designed, that you handed out. It's the observational study where you stood there and you gathered that data yourself. It's the designed experiments that you designed. It's the experiment in the lab that you designed. So all of these that I've talked about so far are what we call primary data. So data you gathered yourself. There is also secondary data or second-hand data. So secondary data is data we get from the internet. It's data we gather from books. So all still relevant data, just not data we gathered ourselves. So it's second-hand data. So somebody else gathered that data and put it into the book or put it into an article or put it into a blog, and you are now using second-hand data. Which data is best? Well, obviously primary data is best because you gathered it, you know that it's good data, you know that it's true data, and so on and so forth. You have to be a little bit more careful with secondary data so that it's not fake news, so that it is good statistical data. It's good, especially if you're looking at experiments, that it was a well-designed, controlled experiment. The data was properly understood, and so on and so forth. So primary data versus secondary data. Okay, so that then brings me on to descriptive stats versus inferential stats. So descriptive stats is when you gather a body of data and you use graphs, charts, tables, measurements such as mean, mode, median, so on, to organize and summarize your data. It attempts to focus our information and reduce it to a manageable size. So very much if you were working in an organization and you're gathering data on behalf of management, you would never present them raw data, so data in a table. You would always present them data in a chart where you have statistically summarized the data and you have drawn a number of conclusions from it, and you have made it easy for them to draw conclusions from the data. So that's descriptive stats. So that's the first body of stats that we're going to look at in your course. And we're then going to do inferential statistics, which is super, super important. It's when a proportion or a sample of a population is studied and conclusions are reached about the entire population. So the table below gives examples of sampling a particular population and how it might be carried out. So in other words, if you needed to survey 30 million actual voters in a UK general election, what you could do is you could take a sample of 16,500 actual voters who were asked who they voted for. Okay, If you wanted to do a survey of all owners of dogs, maybe you were looking for the most popular brand food or dog food, you could do a telephone survey of 1,000 dog owners. If you needed to survey all prison inmates, you might do a criminal justice study of 200 prison inmates. Now you need to be careful there that the sample that you take, and this is for all of these, are from different jails in this case, different age groups, different genders, they did different crimes, and so on and so forth, so that you have a representative, unbiased sample. If you needed to survey the CEOs of all private companies, you get a survey sent to 120 CEOs and you analyse that, and so on and so forth. Okay, now this is where it starts to get very important with words. So there's two types of data that can be gathered. There's what's called quantitative data and qualitative data. Okay, they are also called, quantitative data is also called numerical data. Qualitative data is also called categorical data. Okay, it doesn't matter which name you use, both are equally used throughout. It just depends on what book you're looking at, but you have to know the difference between them. So let me look at quantitative data first, also called numerical. So it's a quantity, or if you know it as numerical data, it's a number. So this is all about numbers. So quantitative data can be counted or measured. Qualitative data then is words, okay, or categorical data. It's words, okay. It cannot be measured, so it's the colour of your eye, for example, blue, brown, green. So it's words. And then how you analyse your data, depending on which type of data it is very important. We then subdivide quantitative data into two more categories called discrete data and continuous data. Continuous data can have any value or any value within a certain range. So for example, if I asked you what height were you, you could tell me you were anything from 5 foot to 7 foot, for example. Okay, but you wouldn't tell me you were 5 foot, 5 foot and a half, 6 foot, so on. So it can be any value. It can be 5 foot 1, it can be 5 foot 1 and a half, it can be 5 foot 2. So it can be any value, albeit within a range. Discrete data, on the other hand, only has set values, or it has steps. So an example of discrete data would be your shoe size. So you are shoe size 5, you are shoe size 5.5, you are shoe size 6, but you're nothing in between those three values. Okay, so that's discrete data. So discrete data, continuous data. So that's your numerical data. Then if we have a look at categorical data over this side, or your qualitative data on this side, we can then bring it into, and again, two words. The first one they call categorical, and the second one is called ordinal. Categorical data in this case, if you call it qualitative data, is also called nominal data. So nominal data, ordinal data. Try not get too upset with the different names, just draw slashes between them. Choose some words to go with and go with that. Just be careful and be aware that there are more than a couple of names. If you're using this book, which is the Project Maths by Gills, you can obviously see the words that's here. If you're using Active Maths, for example, you will be categorical and numerical data up here, and you'll be nominal and ordinal data here. Okay, so what is nominal and ordinal data, or ordinal and categorical data? So ordinal data, we'll go with that one because it's common, has order. So in other words, it's still words, okay, but the words specify a particular order. So if I asked you what position did you come in a race, first, second, third, fourth, fifth, they are positions in a race as opposed to numbers, but they do have an order. Let me give you a better example. If I asked you what grade did you get in a test, and you told me A, B, C, D, E, then now they have order. So in other words, when you say B, I know, oh, okay, you did better than someone who got a C. So that's ordinal data. Another example would be if you were in pain and I asked you to, what's your pain level? Is it low? Is it medium? Is it high? Well, that has order. So that's ordinal data. Then categorical data, or nominal data, I prefer to call it, is just words with no order. So if I asked you what colour were your eyes, you could tell me they were blue, they were brown, they were green, so on and so forth. None of them is better than the other, okay? They're just words. If I asked you what is the colour of your hair, again, no order. If I asked you what your favourite TV programme was, again, no order. There isn't one better than the other. Okay, so this little piece here on the two types of data and the two subsets are super, super important. Let me just share now with you. Okay, so draw yourself some sort of a chart which tells you your types of data. So categorical, numerical, or categorical is words, numerical is numbers, so it's quantitative. Okay, and then these break into their two categories. So categorical data is nominal, or also called categorical. And this is ordinal. Okay, and I remember this one because it has order. I remember this one because it's just words with no order. Numerical data then can be continuous or discrete. So this is any value. This is step sizes or set values. So numerical data is numbers. Categorical data is words. Okay, so this is the chart that you need to know, and then have an example down here of one or two examples of each of these types of data. Okay, and I'll leave that blank for you to fill in. You can check your book, so on and so forth. Okay, or you can ask me if you get stuck. So know that chart, draw it out, go with whichever titles you want. Obviously you can't go with categorical here and categorical here. If you're using categorical here, then you're better off using nominal down here. Okay. Okay, and here are some examples of all the different types of data. Okay, what type of questions do they ask? We'll have a look at this example. A class test in English poetry consists of 20 questions. The resulting score reflects the work rate and aptitude in English poetry of the test candidate. How could the score be reported? what are the possible values for the score, describe the variable in terms of discrete, continuous, categorical, ordinal. So have a look at that solution and understand it. Okay, so the next two words that I want to get onto are univariate and bivariate data. So this is when you're collecting data. So what variables are you measuring when you take your survey or when you're answering your question? If you only take one variable, then it's really good. You get very, very good data on that variable, okay? However, the disadvantage of taking just one variable is that you may have to go back and redo the survey if you think of another question that you should have asked. So univariate data is when one item of information is collected from each member of a group. The data is called univariate, and uni always being one. Examples are height in centimetres, or your eye colour, or your number of siblings. Bivariate data then are when two items are collected from a person, e.g. what is a person's height and weight. Okay, now it's paired data. So in other words, if you're taking your sample from 10 different people, if I was taking univariate data, I could ask them for their height in one question and then their weight in a separate one. But I wouldn't know whose weight was tied to whose height. That's in univariate data. Down here in bivariate data, I know that person X, who is 6 foot, weighs 12 stone. So it's paired data. I know that the person who is 4 foot weighs 6 stone. Okay, so it's paired data. So bivariate data, some examples are starting salary and years of education, your hair colour and your gender, and so on and so forth. So here we would often use a histogram to look at the data. Bivariate data, we would use a chart, which is a scatter diagram, to look at bivariate data. And I'll get on to all of these in a couple of videos' time. Okay, some questions here on classifying data, if you so wish. Have a look at them. If you're not sure, ask me. Okay, so how do you design a good survey? And this does come up as well. So a questionnaire is a set of questions used to obtain data from a population. Anyone who answers is a respondent. So a good survey should be clear about who is to complete it. It should start with simple questions. It should be clear as to how the answers are to be recorded. It should be as brief as possible. It should be able to be answered quickly. It should be clear about the answers. It should be clear where the answers are to be recorded. It should be short and use simple language. It should provide tick boxes. It should be clear about what being asked. It should allow a yes/no answer. It should not be leading. So in other words, you can't ask questions like, isn't Coors Light a lovely beer? You have to ask the question is, what is your opinion of Coors Light as a beer? It should not cause embarrassment or offend. Really careful with this one now and asking people their gender, for example. It should be relevant to the survey, and it should not be open-ended, which might produce long or rambling answers that are difficult to analyse. Okay, some questions here, go through them, see what is meant by leading and so on and so forth. Okay, all the different types of sampling, and this does come up, okay? How do you select a sample? Remember I said the best type of sampling is simple random sampling. There are other types though. So a simple random sampling is a lottery method. Basically everybody's put into a hat and you choose out a new names. It ensures no bias, it ensures representative sampling, and so on and so forth. Often a computer simulation is used instead as names in a hat. Okay, so the second one then is stratified sampling, or there's a strategy. So this method uses the natural divisions of a population such as gender, age, weight, occupation or colour. These are the strata, and they can be used to ensure all sections of the population are adequately represented in any sample. Okay, it is essential when using this method to know in advance the proportion of the population in each natural stratum and to take account of this when selecting the sample. Okay, so again, a very good way of ensuring that every type of person is representative. It can be really good in something where you wanted a mix of race, for example. So within Ireland we have the majority of Irish white people. But if the sample if the question that you were asking needed to have a multinational representation, then stratified sampling would be good in that case, in that you could choose a strata. You could break your population up into strata where you took some Polish people, you took some African people, you took some English people, and you made sure that they were used to answer your survey. Okay, so stratified sampling. Systematic sampling then is there's a system used for selecting the sample. So in other words, select a person at random and then select every 80th name onwards. Okay, or if you were trying to pick people to do a smaller one in your school, you'd pick every 5th person from the roll book or something like that. So you have a system. Cluster sampling then consists of a list of groups of individuals rather than individuals themselves. So you take clusters of people. So a random sample of these groups or clusters is taken, and then observations are made on every individual within your selected group or cluster. So these are popular with biologists, agricultural scientists and geographers, and it's used to cover the survey area with a grid of numbered squares. Okay, so they cover the survey area with a grid of numbered squares. They take a random sample of the squares within the grid, and then they ask everybody within that, or they look at every plant within that grid or that square, and so on and so forth. So cluster sampling. Multistage sample, it's designed to reduce the time and cost of surveying samples from very large proportions. Suppose you want to survey 1,000 members of the population of Ireland at random. You could select 5 counties at random, then select 4 towns at random, and then finally select 50 people at random from each of the 4 towns. Okay, so this is rather than picking 1,000 random people from all over Ireland, because then if you had to do, for example, a face-to-face interview, you'd be driving all over Ireland. So by using a multi-stage, you are going to 5 counties at most. You're then going to go to 20 towns at most. So now to take 1,000 samples or 1,000 surveys is much more manageable. Quota sampling allows the interviewed a certain amount of discretion when collecting the data. Quotas for different sections of the population are set, and the interviewer is allowed to select the sample according to the quotas. So for example, ask 30 teenagers what's their favourite mineral. Ask 20 farmers what's their favourite brand of fertiliser, so on and so forth. Okay. As a result, the interviewer can be a source of bias. This is one of the downsides of quota sampling, as only the views of those chosen by the interviewer are recorded. Quota sample is the first example we've come across of non-random sampling. So quota sample is not random. Okay, it's good in that it allows you to gather data. It may have bias, so it's non-random. Its main advantage is it reduces survey time and cost. And finally, panel sampling collects data from the same sample or more on more than one occasion. Okay, the initial sample can be chosen by any of the earlier methods. Okay, and this can easily monitor long-term trends, measure changes in behaviour, opinions, and is relatively cheap. So in other words, it's when you go back to them again to gather more data. Problems include replacing dropout members. Sample initially, you have enthusiastic people, but they might get pissed off with having to answer the questions again and again, and so on and so forth. Okay, so know the different types of sampling. I've seen, might have been ordinary level, I'm not sure, it might have been a mock, a few of the different types of sampling coming up and a description, and you had to match which one was which. Okay, and then have a look at those questions, make sure they're okay. I'm not really going to assign any questions to do, there's enough words in that one. So that's the words section of this chapter done, and it is important. And when I give you exam questions to do, which I will do at the end of this sequence of videos, you'll see how they get asked. So next video I'm going to look at your measures of centre, which are your averages, and your measures of spread. Thank you.